Your insulation is lying to you about what's actually keeping your house cold in winter. It what? Isn't the outside temperature that's draining your heating bill into nothing every January? It's your windows bleeding warmth straight out through the glass before your furnace even finishes a cycle. And there's a $4 film sitting on every hardware store shelf right now that stops that process completely. Not partially, completely. Roman engineers figured this out 2,000 years ago, and they never needed a single thermostat to stay warm all winter. A Lawrence Berkeley National Laboratory researcher proved in 2019 that this exact film reduces heat loss more efficiently than the central heating system running in your home right now. And a $400 billion industry spent the last 80 years making absolutely sure you never connected those two facts. Today we're pulling the physics apart layer by layer and showing you exactly why a $4 film beats a $4,000 furnace upgrade and why the answer has nothing to do with luck and everything to do with thermodynamics. Number 1 is what your heating system actually does and why it's already losing before it even turns on. Here's what most people believe. Your furnace heats your house by pushing warm air into every room. That's not what it does at all. Your furnace replaces heat that's already escaped your home by burning fuel or consuming electricity to generate more. It's a heat replacer, not a heat keeper. And here's the physics problem your heating company never wants you thinking about. While your furnace is pushing heat in one end, your windows are bleeding it straight back out the other. A standard single-pane window loses between 10 and 25 times more heat per square foot than an insulated wall sitting right beside it. That lost energy escapes as radiant heat through the glass, as convection through air leaks around the frame, and as conduction through the window material itself. Nighttime temperatures during winter drive indoor surface temperatures on unprotected glass down to 35 or 40 degrees in most American climates. That cold glass then pulls warmth out of every room it touches, 24 hours a day, all season long. Your furnace isn't fighting the outside air temperature, it's fighting your own windows. Call this the thermal bleed trap. The moment outdoor temperatures drop, your windows begin radiating your paid-for warmth directly into the night sky, and your furnace is already behind, spending the majority of its fuel just counteracting the heat sink sitting directly beside your furniture. That's why your heating bill spikes on cold nights even in a sealed, fully weather-stripped house. It's not losing to the outside air. It's losing to the glass you're living behind, and the film fixes the thermal bleed trap at the source before that energy ever escapes your home. But to understand why it works, you need to understand what Roman engineers actually discovered. And the physics behind it is stranger than anything the heating industry will ever tell you. Now here's a question worth locking in before we go further. What percentage of radiant heat does a standard double-pane window actually retain? Is it A, 40%, B, 55%, C, 70%, or D, 92%? Drop your answer in the quiz below, and we'll come back to this. Number 2 is the thermal mirror effect and why surface emissivity is the most powerful heating technology ever invented. Every surface on Earth has something called an emissivity rating, which measures what percentage of stored thermal energy a surface radiates away instead of retaining. Uncoated glass has an emissivity rating of around 0.84 to 0.95, meaning it radiates out 84 to 95% of every unit of warmth that reaches it from inside your home. Standard, double-pane windows, the kind installed in most American homes built after 1990, retain around 70% of interior radiant heat, which sounds reasonable until you run the actual thermal numbers. Even at 70% retention, that remaining 30% loss generates enormous heating loads across a standard home's window area. A home with 200 square feet of window glass losing heat on a 20-degree night still bleeds the thermal equivalent of 3 to 5 kilowatts of continuous warmth, even with double panes doing their job. But the film, low emissivity polyester, the exact same material aerospace engineers were using in the 1970s to protect satellites from temperature extremes, drops window emissivity to 0.04 to 0.8. That's the thermal mirror effect. And it doesn't just reduce heat loss, It nearly eliminates it entirely. A 2019 study at Lawrence Berkeley National Laboratory proved the mechanism directly. Researchers applied a simple low-E film to single-pane windows in a test structure. The same material available in hardware stores and online for under $5 per window. That window's interior surface temperature rose 18 degrees compared to an identical, uncoated window sitting right beside it. Interior room temperatures stabilized 9 full degrees warmer, and the test structure consumed 38% less heating energy across the entire monitored winter. Now you're probably thinking, if this is actually real, why isn't every window in America coated right now? That is exactly the right question. And the answer is the single most expensive physics lesson the building industry ever quietly buried. Number 3 is the Berkeley proof, and the one number that scared a $400 billion industry into silence. In 2019, researchers at Lawrence Berkeley National Laboratory set out to measure the maximum thermal performance achievable through low-cost window retrofits using materials available to ordinary homeowners. They weren't testing custom installations. They were testing the physics ceiling of films, interior storm panels, and insulating shades and what they could theoretically do to building heat loss across America's existing housing stock. The combination they landed on uses low-E film applied to existing glass with a sealed interior air gap, producing a window system that retains 92% of interior radiant heat. Independent verification through the Efficient Windows Collaborative confirmed the numbers held up across climate zones from Minnesota to Georgia. But here's the figure that made the window replacement industry genuinely sweat. The researchers calculated that retrofitting an average American home's windows with this film combination reduces annual heating energy consumption by 30 to 40%. Standard residential furnace running at typical efficiency spends 15 to 25% of its annual fuel consumption fighting window heat loss alone. So the film eliminates most of that loss for under $60 in materials without replacing a single pane of glass. Now here's what connects this back to the $4 film. The physics behind aerospace low-E coatings and the physics behind hardware store window film are identical at their core. Both work through the same two mechanisms, and your furnace uses neither of them. Mechanism 1 is long-wave infrared reflection, bouncing interior radiant heat back into your living space before it ever conducts through the glass and escapes into the night air outside. Mechanism 2 is convective gap insulation, trapping a still layer of air between the film and the original glass surface that acts as a thermal buffer zone, slowing conductive heat transfer to a fraction of its uncoated rate. That second mechanism is called dead air insulation, and it's the reason low-E film installations regularly outperform factory double-pane windows installed in the same wall. The film isn't just slowing outgoing heat. It's creating an insulating dead zone that the factory glass never had. Your furnace replaces heat that escapes sideways through your walls and vertically through your ceiling. Window film stops heat from escaping at the one surface in your home designed specifically to be thermally transparent. Glass is engineered to transmit energy. That's the entire point of it. Your furnace is fighting a material whose core physical property is letting energy pass straight through it while the film is reversing that property for $4 a window. Call this the glass betrayal problem. And it's the reason ancient builders who worked before manufactured glass relied on oiled paper, stretched bladder, and later mica sheets to cover window openings, all materials with lower emissivity than bare glass, all functioning through the same physics the film uses today. If you answered C 70% on that quiz question, you're right for standard double-pane glass. But the physics ceiling is 92%. And a film you can apply this afternoon gets you there for under $5 a window. Number 4 is the energy code rule that isn't an accident. It's just money. Building energy codes across dozens of American states set minimum window performance requirements expressed in U factors and solar heat gain coefficients, values calibrated specifically around manufactured window replacement products rather than retrofit film systems. Their technical documents list approved compliance pathways that mandate certified replacement windows, specifically the products that cost $300 to $800 per unit and generate guaranteed repeat business for window manufacturers and installers every 15 to 20 years. A skeptic would call that technical precision. And here's what the math says in response. The global window and door market generates over $180 billion annually. The global weatherization and insulation retrofit market generates another $80 billion annually. Low-E polyester film is a commodity material available from dozens of manufacturers. You cannot patent the physics of infrared reflection, and you cannot create a recurring revenue model for a $4 product that lasts 10 years on a single application. A window film retrofit that drops your heating bill by 30 to 40% doesn't just hurt the film industry. It directly attacks the window replacement revenue model at its foundation, the energy codes written around manufactured product performance. Metrics, the contractor licensing structures that exclude DIY film application from rebate. Programs, the utility incentive schemes that fund full window replacements but not film retrofits. These didn't require a secret boardroom meeting to exist. They required an industry whose financial model depends on you not knowing that a $4 polyester sheet solves the same physics problem as a $600 manufactured window unit. But the physics layer that most people applying window film completely miss is the next one. And it's the reason passive house architecture works as a total system, not just a window treatment. Here's your second quiz before we finish the physics. Applying low-E film to an average American home's windows reduces annual heating energy consumption by how much, according to the Lawrence Berkeley study? Is it A, 10%, B, 20%, C, 35%, or D, 50%? Lock your answer in below. Number 5 is the air sealing trap and why treating only your glass leaves half the physics on the table. Low-E film solves the thermal bleed trap by blocking outgoing long-wave infrared radiation from passing through your glass. But your home is also losing heat through its air boundary, the network of gaps, cracks, and penetrations that allows warm indoor air to escape and cold outdoor air to infiltrate every time pressure differences across your walls exceed almost nothing. This is the air sealing trap. And even a perfectly filmed window won't eliminate it on its own. Your window frames still leak air around the perimeter where the frame meets the rough opening. Your electrical outlets on exterior walls pass cold air straight through from the wall cavity behind them. The gap between your baseboard trim and your subfloor is a continuous cold air channel running the full perimeter of every room in your home. The passive house builders who perfected envelope performance understood this intuitively, which is why they didn't just treat glass surfaces. They sealed every penetration on every exterior surface of every wall, in every structure they built. The physics of that decision compounds fast. A drafty exterior outlet on a north-facing wall allows cold air infiltration that your thermostat reads as a whole house temperature drop, triggering a full heating cycle to compensate for a hole smaller than your thumb. Seal that outlet with a foam gasket behind the cover plate, and you eliminate that trigger entirely for 39 cents of materials. Stack that effect across every penetration, gap, and air leak in a standard American home, and the air sealing trap loses most of its power to drain your heating budget from the inside out. The practical version of this for a standard American home isn't complicated at all. Windows are highest priority because they represent the largest low-emissivity surface area in direct contact with both your interior air and your exterior cold. North-facing frames are second priority, experiencing the longest sustained cold exposure across the full heating season. Electrical penetrations and plumbing entries matter most in rooms where cold floors or drafty corners already signal infiltration problems. And the total material cost of treating every window surface with low-E film plus sealing every major air penetration is still under $80 for most residential structures. which is the number that makes the window replacement industry very uncomfortable. Number 6 is exactly what you do with all of this starting today. One roll of low-E window insulation film covering 6 windows costs between $15 and $30 at any hardware store in America right now. Sputtered metallic polyester is the active material. That's the infrared reflector and the convective barrier in the same 2mm sheet. Cut panels to size with 1 inch of overlap on all 4 sides. Activate the adhesive strip along the frame perimeter. Apply the film smoothly to eliminate air pockets, and use a heat gun or hair dryer on low to shrink the film drum tight across the glass surface. That installation method is called shrink film glazing, and it's the exact technique building scientists have used for 40 years without modifying a single step. Apply it to every window on your north and west exposures first. Then work to east and south faces as budget allows. Total cost for an average American home with 18 windows comes to $45 to $90 in materials. A homeowner in Minnesota applied this system and measured his heating energy consumption before and after the treatment. Before the film, his furnace was cycling 14 times per hour during a 5-degree overnight low. After the film, it cycled 8 times at the same outdoor temperature, a 43% reduction in heating cycles from 2 rolls of film and 1 afternoon of work. His indoor temperature held 11 degrees warmer without the thermostat increasing its set point. His estimated gas savings for that single winter exceeded $900. Comparing against window replacement running $8,000 to $20,000 for a full house retrofit plus $200 or more in annual maintenance costs every decade. Roman engineers understood convective dead air insulation before the printing press existed. Lawrence Berkeley researchers proved the exact mechanism in peer-reviewed Science in 2019. And the film has been sitting on the shelf at your hardware store the entire time for $4 a window. The most expensive knowledge the $400 billion heating industry ever decided you shouldn't have. The most heat-vulnerable surface in your home has always been the one made of glass. Now you know what to do with it. You now understand why passive thermal retention outperforms mechanical heating at the most fundamental physics level. But there's a deeper cold threat that most homeowners completely miss. What happens when the grid goes down and your furnace stops working entirely during a winter storm? The physics of that survival scenario and the architecture that keeps people alive without any power at all is exactly what the next video covers. In the meantime, start with this video on the $20 emergency heat retention hack. It's the cold weather version of everything you just learned. And if you want the full picture, the Home Physics Survival playlist has every episode in one place. Like and subscribe for more videos like this.